Sorry, I'm just reading.
Wait, you heard back from the person? That is cute.
You should ask her. No, because they didn't. Oh, they didn't have any early. I used to try to get this obviously this. See, that's the mentality you have to have to learn when you fall.
Oh yeah, like when you thought they were working on your application.
I had no expectations. I still don't know one person on my big people from the breaks this soon. The only person I know that goes in is like the junior there, and he went to hospital and he got like 36 out of 36 and he's like studying like Russian.
That's a good.
Like Russian like technology and something.
What is that?
Like his whole goal is to go work for like NASA and like Russian.
Oh,
So that's something in Russia, but then the whole thing happened for just like house I don't know.
I can't.
Yeah. Well, it's just, it's Wednesday, Thursday, Friday. 3 groups. Transfer station. We're just gonna make up those classes. Pretty interesting.
Do you want these?
No. I'm not asking for those yet.
It took so long to get stuff like that. It's for a lot of people. Yeah. Just undo pronunciations on drug
Do we need to copy this? 107?
Normal sign.
107 should be old, isn't it?
I don't have it in my notebook. It might
107
be.
was the day before spring break.
On Friday? I was on it.
Oh, okay. Well, it's due before next class, so.
Yeah, I'll do it.
Okay.
Yeah. I don't think I've been to like one math meeting or English meeting this semester yet. No. Yeah.
Oliver
I didn't even pick my B's. I need to do that.
Thompson,
They let you wait so long.
I know, it was so nice.
school business,
Late January.
Really?
Matthew, AJ, William.
No. I don't think anyone.
Do you want to track the weather record? No?
It's literature and poetry.
Who's winning right now?
Jessica. Regular poetry.
Well,
Oh, school business. Blake. Cooper. Zoe, school business. Chloe.
Good morning,
school
FHS. Today
business.
is Thursday, March 28th, 2024. Would you please join me in a minute of silence?
this Friday is the last day for
Wait. Who's this front door? Is it like for me?
I don't know if anyone else is going to guess.
They were basically.
Ask Anthony right here.
Mine was too kind of. You had different.
Please stand if you are able and join me in the pledge. Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right, if you forgot about turning in 106, this would be your last chance to get full credit on it. So if you're not sure if you turned that into Google Classroom, you should probably give me a hard copy. And we've got our one question mini quiz. So this is no calculator, no notes. So clear off your desk, please. Just a quick 2 questions. All of these mini quizzes will be quick. And this one is worth 2 points. But remember that it will be 2 major points. So if you forgot to study for this one, that's something you're going to want to adjust moving forward. These are not meant to be gotchas. This is just me trying to trade you a little bit of AP studying for some points. Again, 2 points is not a lot, but over time these will add up. Okay, so I can give you a few minutes here. And as you finish, if you would just, well, first off, make sure your name's on it and number it is 112. But as you finish, if you would just turn it face down, and then I'll come around and pick it up. So that way I can keep up with who's still working and who's finished. But as you finish, we are going to spend a few minutes on an old handout, number 95. So that's written up on the agenda. But as you finish your mini quiz and turn it over, you need to find that in your binder to be ready for the next part of class.
So Johnson, can I get this?
Oh, I put it on your desk, didn't I?
These are just the papers I picked up.
Okay. Sorry, I'm going crazy, I guess. I thought I came over there and put it on your desk. Still missing Blake. Thank you. Again, if you're finished, just turn it face down. I'll get it out of your way. And you can start looking at what's coming up next, so you can get that out of your binder. Please don't start working on it yet, but, because I do want to set a time. You don't have to supply it.
There's my.
So when you gave this to us was one of the days that I was absent, and we had a test like the next class period. So I kind of assumed that this was test review, and I did all of it except for 5. And
Okay.
then I did 5 when we did in class. Do you want me to do them over again? Because that was several weeks ago.
No, you don't have to, but some of it, just so you know, like, Number 2, this has some stuff we haven't talked about yet. Like, we didn't talk about this till just recently, and this we haven't talked about at all. And then they're gonna do 4 today, so, I don't know, you can just work on something else for another class for a minute.
All right. Thank you.
Oh, sorry, there, one of these was supposed to be his. Which one do you want me to grade? I didn't mean for you to do it twice. I'll let you pick. They're just different forms.
I think I'm right.
Okay, that's fine. I didn't mean to make you do double and then this way. It's at least fair for you. Okay, if you need an extra minute or two there, that's fine. You can keep going. I'm gonna move the homework basket over to the side of the room. You can just come turn it in as you finish. But most people are finished here, so let's go ahead and move on. So again, this is not meant to be a gotcha, but if you didn't remember how to do it and you didn't review it, then you might lose a point or two towards your grade. If you make that your habit, then over time that can impact it for the positive or for the negative. So again, short of a few classes that I know we're going to have some different things coming up, I will try to give you one small quiz like that each class period. So before I forget, you can see that I've got another one for you next class. It's under upcoming agendas. It will be on U substitution. So again, something that you should feel comfortable with, something we've been doing for a while. But if you don't know if you're competent or you're just not sure, then you should look back at your handouts where we did U substitution. I can't promise to do this on every one, but yesterday I also posted 2 optional Khan Academies on Google Classroom that the questions will come from. So if you practice those for extra practice, you may accidentally work the one that you end up seeing, or 2 that you end up seeing. So all these mini quizzes will be short, 1 to 5 questions, 1 to 5 points. Sometimes it might be 2 questions and 4 points, but in those type of cases I do partial credit or something. So again, just make sure that you adjust accordingly, please. Okay, so the main thing we're going to look at today is an extension of what we did last time. Last time we rotated area around the X or Y axis, which made 3-dimensional shapes, and we practiced the integration of how to find the volume of those 3-dimensional shapes. We're going to do basically the same thing today with 13 and 14, but 13 we're going to rotate it around lines that are not just the X or Y axis, but it's basically 95% the same thing we did last time. So it's a little bit more of a reteach there. And then the circuit 114 is a good mixture of some regular disc method, some regular washer method, like you guys practiced just a touch last class, but you need to practice that more to be good at it. And they'll have a couple on there eventually, like the notes that we'll do from 113. But I originally had us doing this one more FRQ from handout 95 last class, but then on my 8A class, it was a little bit too much. So I ended up taking it off of Tuesday's lesson and added it to the start of Thursday's lesson. So this packet, 95, remember this was all 6 FRQs from 2022. Again, very recent. Of course, your FRQs are not going to be the exact same type, but some of them should be duplicates. So we did a few of them in Chapter 5 because they were Chapter 5-ish, and we got the double FRQ practice with Chapter 5 practice. We did FRQ 5 in Chapter 6 so that it was double FRQ practice with Chapter 6 practice when we were there. And then I think just randomly we have done FRQ6, which was more of mostly last semester review stuff. So eventually I want us to go over all 6 of these, give you time to do all 6. We're still going to skip FRQ2 because FRQ2 has one piece in there, is one of the last things I need to teach you that I haven't shown you yet. So we're not going to look at that one yet. But FRQ4 is all stuff we've talked about. Doesn't mean it's all easy. In fact, I'd say a lot of it is first semester-ish, but there's a little bit of second semester stuff. So I'm just pointing out this has nothing to do with the current unit. This is more just kind of as we get closer to the AP test, it's a little bit, class will be a little bit more hybrid. Some stuff will be focused on this last unit, some stuff will be focused on AP review. So I feel like spreading it out a little bit thinner makes it a little bit more doable. So FRQ4 is the one I want you to put a full effort into. This is a no calculator one. If you want to write the average in the top right, the average on this one ended up being 2.97. So maybe a touch higher than normal. But I would like you to give it the best full 15-minute effort that you can. And I will start the timer now. And a couple of these points are pretty tough to get. Not that the questions are hard, but they're just kind of demanding points. But that could be how your AP test is. So it's good for you to see how you do before you hear how they grade it, and then you can figure out what kind of adjustments you might need to make as we move forward. And again, this won't be graded for accuracy, so don't stress out. Just all I ask is that you're giving it your best effort. And of course, after you see the grading, try to find a point or two that you could get next time that you didn't get this time. Yeah.
I don't think I have the packet.
I'll see if I can find another one. You still need to look for yours though, because eventually I'm gonna have to turn all these in. I don't want you to have to redo them, but if you can't find your others, you'll have to for the homework points. All right, so as I said, I think this one's probably a little stickier, especially part D, because that was a related rate, and we have not reviewed related rates since we needed them last semester. Not to say that you couldn't get some of those points, but again, at the top of your page there, you do have the link to the scoring guide. So if you know, some of these scoring things, there are some specific details, like common stuff that you might have questions about from part A. So I don't know that you need to pull that up right this second, but if you have questions about your grading, you might read that. So, as we did with other practice FRQs, I do insist that you do your corrections and additions in a different color. If you need to borrow something of mine, please come get it and put it back when you're done. But part A was worth 2 points. So to estimate the second derivative, you could just use the slope formula from the first derivative. So to get the first point, you had to get the answer, 0.2, or anything equivalent to that. When I worked it out, I got 0.6 divided by 3. But remember, you don't have to do any arithmetic. So this is fine, 2 over 10 is fine, 1 over 5 is fine. Anything that's equivalent to 0.2 gives you that. But you also have to have some work with it. So whatever your answer, if you got that or something equivalent to that, but you didn't show where it came from, like something like this. Actually, this is fine too for a final answer, because this is all arithmetic too. But you needed to show something about where those numbers came from. So if you came up with that as an answer, but you don't have where it came from, then that's just as simple as you need to force yourself to try to show some more work. Okay, also they gave 1 point for the units. So if you didn't know to put the units, and especially if you had extra time, you should have been rereading the questions. Indicate units of measures. So you get 1 point if you said centimeters per day, or you could write it like that. That's the same thing.
If
Yes.
you didn't get the answer right, but you put like what unit it should be, would you get a point?
In this case, yes. 1 point was just for the unit. Yes. Okay, so that one to me wasn't too bad, because you were just estimating with a little bit of information you had in the table. B, I feel like, is a little bit harder, and this one will be a little bit easier when we get to review this, but B was referring to something called intermediate value theorem. So basically, the slope at 0 was negative 6.1. The slope at the slope at 3 was negative 5. And because this is a twice differentiable function, means that you could take the derivative of the derivative, and if something's differentiable, it implies that it's continuous. So I know the graph's not jumping around. I know there's no sharp turns. So if the slope was negative 6.1 at 0 and negative 5 at 3, then it had to have all of the values in between that, like negative 6. So if you express that in words or in math symbols, something about how negative 6 is bigger than negative 6.1 but less than 5, then you can have that point. Yeah.
Do you have to say the words intermediate value theorem?
For the second part, you will have to, yeah. So they don't usually be that picky on this. Well, okay, that's a lie. There's one case where you wouldn't have to say that. To get the second point, you need to have the correct conclusion that there is such a time, but you also have to have the justification. So the easiest way to say that is by extreme value theorem, or IVT. I'm sorry, not extreme, intermediate value theorem. Intermediate value theorem is the one that talked about if your graph was continuous and not sharp edges, it's got to hit all of the values in between the start and the end. So if you said, I know that's true because intermediate value theorem, or IVT, then you can get the second point. The only other way to get that point is for you to explain IVT without referring to it. So that is obviously much more difficult. But if you correctly explained why that had to be true and you didn't refer to IVT, then you could get that point. But again, you'd have to refer to talking about how continuous and differentiable was important, how that means it's going to hit all the values in between, and since -6 was in between, then that would be fine. But again, that one's pretty hard. Usually they don't make you specifically refer to the theorem, but that's what you needed for the second point.
Wait, you're able to say IVT, right?
No. Yeah, that's a common abbreviation. IVT is fine. MVT is fine for mean value theorem. EVT is fine for extreme value theorem. Those are all big theorems in calculus, so they allow those. You shouldn't be making up your own, though. They don't like if you make up your own acronyms, but yeah, those three are fine. Okay, I feel like the third one was a little bit more in line with what we've talked about recently. So 4 subintervals to estimate an integral. So this would be like area under a curve, and since it wanted 4, but it also gave you a table, so it gave you the information you needed, I would say you needed to read the question carefully. This was supposed to be a right Riemann sum, so that told you what numbers to pull and what numbers not to pull. But if you showed the form of where that came from, showing that you added up 4 things and where the numbers were being called from, you got a point. And you get 1 point for the answer. So again, your answer could be -51, or your answer could be all of this, because this is all arithmetic. Again, I know this seems backwards from what you guys have always heard, but on FRQs, you're crazy if you do this arithmetic without a calculator, waste your time, and hope that you don't mess it up. Because if this is right, and then you write down something wrong, you just lost the point. You can stop right here. You don't have to do any arithmetic at all. Yes, Harper?
I did not write down anything for the first point, like the form of the right Riemann sum, but I did draw a picture that I think showed it. Would that get me a pointer?
Possibly. Did you show this
Yes.
for the second point? Okay. Well, down here in one of the scoring notes, this is why I said sometimes y'all might want to read the specifics of the scoring notes. If you wrote this down, it actually earns you the first and second points. This counts as the form of the right Riemann sum. So really, to get both points, you could have just written this right here. They let that count as the form, and because it's just arithmetic, it would count as the answer. So now again, if you read the question too carefully and you did like a left Riemann sum or a midpoint Riemann sum or a trapezoidal sum, you're going to get different work and a different answer. So important that you read the question before you spend time trying to work these things out. But I feel like those 2 points were easier to come by than part B. Okay, part D is not too bad, except that, again, we just haven't had time to review this yet, so this will get easier. But this was a related rate. Related rates were things that change over time. So we take the derivative with respect to time. That gave you the formula that you needed. And I'm going to write this the other way as well, because I don't think many of you wrote it like this. But when you took the derivative of v with respect to time, you have to have a v prime, because v and t are not the same thing. This was an r squared times h, so you had to do the product rule. So you could have a 2/3 pi rh and a 1/3 pi r squared. You had to see that you had to use the product rule. The derivative of r squared with h left alone and the derivative of h with r squared left alone. Now within that, you took the derivative of r one time and then you took the derivative of h one time, and it was with respect to a different variable. So this chain rule point is testing to see if you remembered when you took the derivative of r with respect to time, did you put an r prime? And when you took the derivative of h with respect to time, did you put an h prime? This is just the other notation. These are saying the same two things. Yeah.
If I was using the product rule correctly, but I still remember like R prime and H prime, do I get the chain?
Yep, you would get the chain rule point. And then finally, to get the answer, to get the last 9th point, you could either have this, but once again, you need to break that habit. You should have just stopped right here. All of this is arithmetic. You did not have to try to figure out how this simplifies. It's a waste of time, and if you make a mistake, you lost the point, whereas you could have had the point if you just left it alone. Now, before I give you a chance to ask a question or two more, I want to be clear. This is considered arithmetic because this is all numbers. So this is perfectly fine to stop here. But like in the last question, this is not considered just arithmetic. You need to actually plug in what this is and plug in what this is. So stopping here would not be considered arithmetic. Because just because you know it's supposed to be r prime of 10 doesn't mean you know what r prime of 10 is. So again, don't have to simplify arithmetic, but if you have functions or derivatives or second derivatives at a value, you actually need to plug in the values for those. Alright, so again, this doesn't have anything to do with what we're currently doing. This will be a little more familiar and easier to you as we get more time for AP review. But the average for this was 2.97, so if you were close to that, I wouldn't be too worried about it. If you felt like this was one of the hardest ones you've ever done, you might try it again. But for all of you, please try to find 1 or 2 points that you feel like you could have gotten if you had spent more time, read the directions carefully, reviewed one topic, whatever the easiest 1 or 2 points would be. Just make sure that you could get those next time. That's all that I'm asking. But do y'all have any other quick scoring questions that you think I would know the answer to? Okay, so we do have just one more of these before I have you turn in this packet and give you a chunk of homework grade. But again, the one we haven't done still has a topic we haven't covered yet. So we will actually start to look at that topic on Tuesday. But now back to the current unit. So current unit, we have done L'Hopital's rule is a piece of that. Area between two curves is a piece of that. We talked about and practiced both of those before spring break. Then I've only seen you one day since spring break, plus today. And that was when we've rotated areas around the X or Y axis to get volumes and how integration can find the area of that volume, or the volume, how integration can find the volume of those three-dimensional shapes. Sorry. So I need to show you the one last little step to that in number 113, and then I can give you the rest of class to start to actually practice a little bit more to that. I know y'all did the 2 Khan Academies, but these question types take more practice than that to feel comfortable in them. All right, so this is still basically a new topic to you. So the first 4 questions are just review on what we talked about last time. Now all of these are pretty easy examples, but it still kind of gives me a chance to remind you of all the important stuff. So again, 1 through 4 is just a reminder of what we did on Tuesday. So I've got a bunch of lines here that I would probably graph. Y equals 3, X equals 5, Y-axis, X-axis. All the intersection of those lines are going to create some area. And then we're going to rotate that area around the X or Y axis. So questions 1 and 2 are about disk method only. So the easy part is, if this is rotating around the x-axis, I know it needs to be dx. I know this stuff needs to be in terms of x, and I know the limits of integration needs to come from the x values. Well, if you sketch a picture, usually that's enough to see what x values you're interested in, 0 to 5. You're going to think I'm crazy for this, but yesterday, when students started the circuit, the first 4 or 5 questions I had were students who either forgot 1 or 2 parts of this. When you rotate this, like you take this point and you rotate it around this line, it's going to create cross sections that look roughly like this. Those are circles, and the area of a circle is pi r squared. Again, the first 4 or 5 questions I got yesterday, either they forgot the pi or they forgot the square on the radius. So that's why I'm emphasizing that. But we have an infinite number of circles, that's why it's pi r squared. The part that you need to slow down and be as careful as possible about is what r is. So if you sketch the picture, you sketch in a couple cross sections, you can visualize each radius. And for this question, it looks like the radius is always 3. So since this is, these numbers are so nice, I'll just go ahead and do the integration too. When we finish this and you move on to the circuit, if the integration is this simple, go ahead and just practice it by hand, but if it's complicated, just let your calculator do it for today. So that's how we rotated stuff around the x-axis if it was just this method. There was no missing area next to the line we rotated, so there was no missing volume. So the only difference with rotating around the y-axis was it was dy. This stuff needs to be in terms of y, and the limits of integration need to be y values. So again, unless the functions are just something crazy, I think it's worth the effort to graph them to see the trapped area. I think this is the same area as question 1, but this time we're going to rotate it around the y-axis. So again, you don't have to write this little circle with an arrow on there. College Board doesn't expect you to do that, but it does kind of help remind you which way you're going, so it's still not a bad practice. So take a point furthest away from the line you're trying to rotate it around. This would be the furthest point. That would look roughly like this, or maybe roughly like this. But drawing in a couple of the cross sections is going to help you find the radius length. So we're going to do an infinite amount of circles. That's why it's pi r squared. The infinite part is the integration. I can see now the y values go from 0 to 3. Again, sometimes you have to do that algebraically, but if it's a simple enough picture, you can see it. And then the most careful part you need to be is the radius part. But if you have a picture, it's a lot easier to see that the radius was always 5 for this question. Again, the radius has often got x's or y's in it, but that doesn't change the setup at all. All right, again, since this one just integrates so nicely, I am going to put one mistake in here though, because I want to see if you can catch it. What is wrong about what I wrote?
You should have scored 5.
Huh?
You should have scored 5 initially.
Oh, well, that too. I don't know how I got the right answer, but
It's not why.
very good. If this was an FRQ, you might have just lost a point. If you're integrating with respect to y, why did this 25 become 25x? It should be a 25y. That doesn't change the final answer, but on a FRQ, if they had assigned 1 point on if you integrated it correctly, it's technically not correct with x's. It should be a y. So, okay, so 1 and 2 were review on how we did this method, rotating around x-axis and y-axis. Do you have a question about either of those two? Okay, then 3 and 4, we'll practice one washer around the x-axis and then one washer around the y-axis. All right, so most of the work is still going to be the same. But one thing that you definitely need to notice, I mean, the questions aren't going to come out and say, hey, find this volume using this method. Hey, find this method using washer method. They're going to expect you to know when to use this versus washer. So, if I rotate this around the x-axis, which would be down here, not up here, how do I know this is a washer question?
It's bounded by y equals 1 and the y-axis.
Okay, one more time.
It's bounded by y equals by 1.
Okay, so basically, this line, you're trying to rotate it around, the area that's trapped doesn't hug up next to this. And this missing area, when you rotate this shape, ends up being missing volume. So, alright, so x-axis is still going to be dx, it's still going to be the x values, it's still going to be an infinite amount of circles, but if it's washer, we need to think of it as big R squared minus little r squared. So the big R is going to come from taking points on the outside of the enclosed area and rotating them. Since they're the furthest from the line of symmetry, they're going to create the biggest radius. So that's the big R. And I can see this would be 3, 3, 3. So big R is 3 in this question. Okay, the small r is going to come from points close on the enclosed area, closest to the axis you're rotating it around. So that would look like these two, and they always have a radius of 1. Again, usually these aren't just numbers, but that doesn't change the setup. Again, I just picked easy stuff because this is all just a reminder anyway. So this would all come out to be 8. If I integrate 8 dx, that would be 8x. Plug in 5 to get 40, plug in 0 to get 0, so 40 pi. Okay, and then the last one that is no different than what we talked about last class, just for a sampling of everything. Now we're doing washer around the y-axis. So I know it's going to be dy. Since it's washer, it's going to be big R squared minus little r squared. And honestly, I don't even really know it's washer until I think about the graph. So okay, so if I'm trying to rotate it around this line, the biggest radius is going to come from the points furthest away from the line of symmetry, or the line that we're rotating it around. So the big circles, the big cross sections are going to look like this roughly, and their radius ends up being this length, 5. The small radius is going to come from the points on the enclosed area closest to the line you're rotating it around. So we draw on a couple of those. We can see they're always the same. They're always 2. So little r is always 2. So the integration piece, this would be 25 minus 4, which would be 21. Integrating 21 dy would be 21y. Oh, I didn't do the bounds, but the bounds from the picture are just right there, ready to be used. Plug in 3 the first time, 0 the second time. Of course, 0 makes a lot of it, the arithmetic be nice, but I should end up with 63 pi units cubed, because this would be volume. Could be centimeters cubed, feet cubed, miles cubed. Volume units are always cubed, just like area units are always squared. Actually, I probably should have put units on these so that we could practice that, but okay. So for the new step, 5 and 6, it's still going to be 95% the same thing. In fact, it's only about one sentence that you need to hear to be able to do the same things 1 through 4 on questions 5 and 6. So without telling you what that is and just trying to dive into this, and then you can kind of see what's going to come up differently. So we still got some equations to graph. We still get a trapped area. We're still going to integrate an infinite number of circles. Maybe washer method, maybe this method, I don't really know yet. But here's the only thing that's different. I'm not asking you to rotate this around the x or y axis. I'm asking you to rotate this around y equals -1. So you should probably graph that as a dashed line, and even better if you do the little circle thing so that you can visually remember which line you're trying to rotate it around. Yeah?
I think you did like the y and x backwards.
Yeah, thank you. 1, 2, 3, 4, 5, 6. Here we go. Thank you. So, here's the only new problem this introduces, really. Do you think this should be dx or dy? If you just had to guess.
dy.
Okay, why do you think dy?
Because it's like on the same axis, just like one down.
Wait, you think this is not the y-axis though?
I know, but not on the axis. But like, it's like parallel with the axis.
Okay, but it's not parallel to the y-axis either. It's parallel to the x-axis. I think your reasoning's right, but you said it opposite. So it's not that it's dx and x values when you rotate around the x-axis. It's actually dx and x values when you rotate around a horizontal line. It's just that the x-axis is a horizontal line. So anytime you rotate around a horizontal line like the x-axis, it's dx, and the limits of integration come from x values. The rest of it, I mean, you might think the radius is a little bit harder. Now I can see that this is washer method because the area next to the line I'm trying to rotate it around is missing. So when we rotate it, it's missing volume. But to me, it's really the same skill now. So you just have to be careful not to rotate it around the x-axis. You need to rotate it around y equals -1. So that means the radius would be, big radius would be 2. Small radius would be 1. I guess if your picture is not very good, it could be a little harder. But so we get 3, 0 to 6, that should be 18 pi. Again, since I rigged these to just be numbers, the integration's easy enough. We should just do that. All right, so you can probably guess what's going to happen on the next one because I'm trying to show you a little bit of everything here. But new thing on this one, if you rotate around a horizontal line like the x-axis, it needs to be dx. These need to be x stuff or numbers, and these need to be x values. So in the last one, make sure I graph this one correctly. We are going to rotate it around the line x equals 7. So make sure that you're showing yourself where x equals 7 is. A dashed line kind of works a little bit better because it emphasizes it. And so now, again, I think you could probably guess here, but when you rotate things around the y-axis, we integrated dy, but it's not really that it's a y-axis, it's that it's a vertical line. Anytime you rotate around a vertical line like the y-axis, it's going to be dy. You're going to use y values for the limits of integration, and then everything else should be the same as what we've been practicing. Missing area tells me there's going to be missing volume, so washer instead of disk. Big R is going to come from the points furthest away. That would be 7. Small r is going to come from the points closest to the line we're rotating it around. 2. Uh, 49 minus 4 would be 45. Integrate 45 dy would be 45y, and 90 pi is the final answer. So, I don't know if you need to write this on the top of your page, but again, the only thing, well, I wanted to remind you disk method and washer method, because you've barely practiced that. But it's not that when rotating around the x-axis that it's dx, it's when you rotate it around a horizontal line like the x-axis. It's not dy when you rotate it around the y-axis. It's dy anytime you rotate it around a vertical line like the y-axis. So that's really the only thing you need to be able to rotate it around any axis. Okay, any questions about this new part? Yeah?
Is it possible later on in calculus it would rotate it around different lines, like y equals 1, or not y equals 1, but like...
Yeah, I think maybe, I mean not in this class, but I think you could maybe rotate something around like y equals x or something, like a line that's at a slant.
I mean, obviously that's getting to the next level.
Well, not just the next level. That would probably be more of a Cal 3 topic, I think. But I'd have to think for a few minutes about how to even approach that. But yeah, eventually you could do something like that. But I also don't know if there's like any real applications behind that. So other than just doing it to see if you can do it, it's kind of silly. So I mean, because in real life, if you were trying to rotate it around y equals x, like why wouldn't you just rotate your shape and then just make it the y-axis to make your life easier? So okay, so I need you guys to get more practice with this stuff. So that's where I've got the circuit for you. Again, the first questions are just going to be disk method only, I think. Then they're going to mix in some washer method, and then eventually they're going to ask you to rotate around lines that are not the x or y axis like we just talked about. So I'd like you to spend the rest of class working on that, please. 10. We've got just under 40 minutes. And again, if the integration is very simple, like I think question 1, the integration is really simple, go ahead and do it by hand. But when the integration is kind of messy, like I'm just glancing at my work, question 16, question 18, the integration is pretty messy, feel free to just throw it in your calculator and let your calculator do the integration on those. So again, more integration practice is always good. But my main concern on this is you practicing setting up the pictures and setting up the integration, not on actually doing the integration. So. Okay, I'm going to finish grading these mini quizzes, finish grading the homework. That gives you a chance to get a few questions under your belt. And then I'll come around and try to help out with whatever's giving you issues. But remember my warning from yesterday, my 8A class, the first 4 or 5 questions they asked me was about they either forgot the pi in pi r squared or they forgot the squared in pi r squared. So that would be a good thing to ask yourself if it doesn't look like it's coming out right.
memorize your lessons for Monday.
Thank you.
Of course.
What is this going to do?
I don't know yet. I plan on giving a little more class time than just today, but I don't know if it will be next class or not. Bless you.
Yeah, but then. Yeah, but I think probably gonna see what I got wrong too.
Does that make it? Right, just like.
What is it saying? It has to be just one of those, it has to be one of them, because it's not that Y.
The one furthest, the points furthest from the line you're rotating around. Well, yeah, but is this the trapped area?
Yeah.
Well, then these points are furthest, is it the y-axis?
The X.
The X, okay. Then these points are further from the x-axis.
So that's
So that would have to be the right.
Wait, yeah. Yeah.
Are you still asking me?
Wait, no, the other one is the other one.
Make sure that you keep this mini quiz in your binder. Especially if you missed one or both of them. After we have a few, I might give a mini quiz where I might take one more question for this type and maybe one more question for the second type. Something like that, so. I tried to write some notes if you missed
That one was just, I think we worked too quickly, but maybe not through the 2X. Y'all got one on the circuit that is giving you more issues. Y'all have anything from the circuit yet that I can help you get past? No?
Like off the x-axis and the y-axis, and I have I was supposed to know exactly what the radius is, because like I thought it was square root of y, but that is maybe
T minus square root of y is what I got. Well, you could just let your calculator do that one. I mean, it's not bad practice, but. Oh, I didn't even read that. Again, I'm more concerned about y'all practice setting them up. But yeah, 2 minus y squared is perfect for art. But also, I have that as number 16.
well, yeah, I wasn't doing them in order, I was just.
Oh, okay. Well, the thing is, these usually build up in difficulty, so if you do one of the last questions early, it's gonna seem a lot harder. But, I mean, that radius is pretty hard to get, so that was pretty good to get that, but, yeah, in the end, I got 8/3 pi, and it worked out for me.
Yeah.
The little r, I had no little r there, because your area is supposed to be trapped by the x-axis, and once you shade it, isn't trapped by the x-axis, you have it trapped by the y-axis. So, rotated the wrong area.
This is the area you're trying to find.
Do y'all have one I can help you with yet?
Yeah. What is y equals 4? See, I did the wrong function. I went to the function class.
She's gonna be ready for you.
Yeah, I'm ready for that one.
I specifically said, like, type in.
Yeah, I did read it, I just clicked on the link, so. I was very
Well, make sure that you figure out why it's so wrong,
Yes.
because I probably will throw another one
Okay.
at some point, but I will
So
warn
I
you.
just needed some parentheses.
Well, when you plug 2x into p squared, it's 2x squared, so 2x times 2x is 4x squared. Now, I will also say with these circuits, I don't know if you guys noticed, but generally, the first questions are supposed to be a little bit easier, and then they're slowly supposed to build up in difficulty. This one probably more so than others, and I'm only pointing that out because if you get one wrong, and then you try to work one of the last questions, it's gonna seem like the difficulty jumps up quite a bit, so. That's okay, you can still have a chance of getting it, but the skill level should rise slowly, but that depends on you doing the first ones correctly to do them in order. And you must be confident. Ken,
Yeah. I don't like these.
you're more confident than me.
Well, I'm wrong a lot, so it's just.
You need to get one of those pens that you can erase it. Have we talked about that before?
I think so.
Okay.
Yeah, I've
Yeah,
been
they're pretty
using
cool.
pen in your class for 2 years, so.
Yeah.
Not right now.
I've gotten better, I don't use pen on tests anymore.
I went yesterday. What's Okay, I'll copy.
Okay, does anybody have one I can come over and help you with? Okay, let me know if you find one in the next few minutes, please.
You said they scale with difficulty?
I mean, yeah, it should be like a
Last
slow
que- like the
increase.
last
Yeah.
question should be the hardest.
Usually, yeah. Well, maybe not the hardest.
I got
but-
stuck on 2, and then I randomly chose the last question.
Wait, which did you get for 2?
56/3. Oh, for 2? Oh no, I just randomly chose.
Oh, okay. What box do you think that is, though?
Number 1. Oh, the last one.
That's not the last one. I have that as number 6.
But the answer I got for it is the answer. Oh, so that is
So that maybe. Well, what'd you get for number 5?
Oh, not number 5. I chose this one randomly.
Oh, you chose it randomly.
Because
Okay.
I was stuck on number 2.
Oh, okay. I got you. So, all right.
Is the answer for this one that?
Close, but not. It should be 32 pi thirds.
Oh, you're pulling on
We got the same, we just got different answers.
That's real weird. Oh, you put a pie. Oh.
128 pi over 5.
Yeah, I'm getting the same answer for 5 and 8.
Good with that.
So this one's wrong.
This is not a washer question.
Okay.
Because if you're rotating it around y equals 4,
Mhm.
if this is the trapped area, there's no area missing
Okay.
right next to that, so it's only a
Okay.
disk
So
method.
it's not this area. It's this
Oh, wait,
area.
I'm sorry. Wait, I mean, I told you wrong.
Wait, I don't know.
Okay, well, first off, your area is different than mine. On track-
Yeah, that's what I had. I just erased it. 'Cause I thought you
Oh,
were
okay.
the way. So it's this area.
Yes, and so it is washer because now you have some area between that's
Mhm.
missing. So, big R is 4.
Mhm.
Small r, this length isn't
Mhm.
what you have.
Okay.
Because if you call this, well, this is like the radius, you're saying it's x squared. I know why you're right next
Yeah.
to the 4. But that would be, think of a couple test points. If x is 0,
Mhm.
your radius, you're saying your radius is 0 there? Because 0 squared is 0. but your radius is actually like 4.
Okay.
You see what I'm saying?
Yeah, so I do,
Over here, this is what?
so it's x
2.
squared.
Well, it's 4. The radius is 4.
Uh-huh.
Subtract however far you have to go to get to that x
Okay.
squared line.
Oh, that's confusing.
Yeah, those are harder.
Okay, thank you.
Yep.
On this one, does that make 7?
I have that as number 7, but I got a different small radius.
No, 4 squared minus 4
So y equals, oh, so it'd be 6.
Yep. And that should fix it. Alright guys, we are down to about 5 minutes, so let me tell you where you need to be by next class and what you don't need to worry about for next class. Number 1, this circuit 114, you do not have to have it finished by Tuesday. I will give you a little more class time on it before I sign it for homework. But if you feel like you're working slower than other people, then it would probably not be a bad idea to do 1 or 2 more questions. But that does not have to be completed on Tuesday. What is due and expected by Tuesday is what's listed under homework. So the 107 needs to be turned in. That's the other assignment we did after Chapter 6 test before spring break. So, as I said at that time, you probably wanted to do it, get it over with, so you didn't have to worry about it for homework after spring break. But I've even given you an extra week to get all of that rounded out and stuff. So I need that in Google Classroom by Tuesday. And unless you're 100% confident about your U substitution skills, you should spend a couple minutes reviewing that for a 1 to 5 question, 1 to 5 point mini quiz next class. I also posted in Google Classroom 2 Khan Academies that you could practice if you don't know what to practice, and the quiz questions will come straight from Khan Academy. So you might accidentally practice the actual questions. I feel like that's a trade-off for you doing the extra practice. So those 2 things under homework have to be done by Tuesday, but you don't have to have the 114 done by Tuesday. But you've got just a couple minutes, so if you still have my calculator.